Alright, then let's move on. Let's try the 5 independent variables. Right? So it means we need one more slope coefficient, I would say whatever, 4, and true parameters 5. Okay, then nothing to change, then yeah, you could write x4 something, right? Then I'll say simply 3 times rand t comma 4, right? So then I don't need x's. Actually, it doesn't matter too much either, though, right? Nothing to change. Yes. What about this? Now this is 5, right? This is 5, say, right? Yeah. This must be 6, like this. And here 5 now. What else? Nothing, right? Let me run it. Alright. Oops. What's wrong? Line 13. Line 13. True beta 5. Oh, sorry. Yeah. Yeah. True beta 5. Right. Oops. No. This is constant term, so it must be once. T comma 1. Oh, sorry. Capital T. Is it running? Yes. It runs very well, right? Okay, then, yeah. Then let's make it a bit more generalized. Okay, so then so this is DGP, and this part will be replaced by data loading. Okay, and then so once y and x are given, what about this 5? 5 is what? 5 is the number of independent variables. So then I would say k equals what? Cos of x. So then this just k. Okay, yeah. Okay, and this I k, right? So then what about this? This k plus 1, right? So then this should be k, right? Right. And then I don't want to plot these prior posterior figures anymore for now. Yes, just for now. Control R. So then let me run this again. Right. Okay, we got the result. Okay. So then let me show you how to load the data first, and then I'm going to make a function. Okay. So then let me save it. Save as what? I'm gonna do this with just data analysis. Okay. So then where is data? Sorry, before then let me make a new folder. Okay, so then yes, let me make new folder here. Okay, new folder. I'll say data analysis. Data. This is the first folder. So 0 1. No, say UIRP. Okay. So because we are going to use the data for uncovered interest rate parity condition. Okay. So then I'm going to cut this and paste it here. Okay. Okay. Let me open it. Just let me run it just to make sure it runs. Yes, right. And then where's the data? Data is here. Okay, you can find it on the in the course material, of course. Here, copy. So just here, copy and paste it. And then let me open it. You can open the Excel file within MATLAB. Okay, it should be coming up. Why it takes such a long time? Maybe it's because of my computer or something. Yes, it's coming up. Yeah. Oops. Yeah. All right. Okay, here. So data is here. Do we have three data? This Korean US dollar, Korean won US dollar interest exchange rate, and Korean interest rate, and the US interest rate. Okay. So then the data ranges from 2004 to 2012, I think. Yeah, 12. Right. So this is just an example. Okay. And this is exchange rate, not depreciation rate. Okay. Not depreciation rate. Then, okay, let me show you how to load the data. Okay. Before then, we don't need this DGP anymore. Okay. So now this data loading. Okay. Okay, let me show you. But usually you forget how to load the data whenever you have to, because usually I do because I'm too lazy to memorize. Okay, so then just let's Google it. All commands you can imagine. Everything is in the on the Google here. Data loading and MATLAB and Excel. Just list the keywords. Okay, here. Okay. All right. It should be XLS read. Okay. Where is it? Yeah, you can do this. This is quite traditional, though. Right. You can do this. This is not the favorite way. Okay, let me do this. Let me search another way. Yeah, XLS read. Okay, let's try this. Okay, let me show you how to do this. So data, of course. XLS means Excel. Okay, Excel read Excel files, and then first one should be the file name UIRP _data. The second input is the seat name. Where is the seat? Seat 1, right? Seat 1. Seat 1. The last one is here. The location of this location is what? B2, and the bottom line is B2 and D98. B2 D98. Is that right? Yeah, D98. So once you define this location, I mean the upper, I mean the first line and the first column and first column and first line here, and then this one, last column and last row. Then the MATLAB will read these data. Okay, does it make sense, right? Okay, it's done. Okay, just to make sure it MATLAB reads this file correctly. Okay, let me run this. Let me run. And is there any error or something? It's still running. I don't know why. Maybe my computer is getting slower. I don't know why. Yeah. Right. Still busy. Right, it's done and no errors. Okay, and then let's see the data here, and click the right button of your mouse and open data. It's very weird. Maybe it's because I'm recording this my screen. Yeah, I can see the numbers very correctly. All right, it's done. Yeah. So then, what's the y? Y is the not really. The first column is exchange rate, but what we need is depreciation rate, and depreciation rate is the actually just growth rate or change rate of the exchange rate. So then and the depreciation rate can be computed two ways. The first one is just compute the depreciation rate by the growth rate, and the other way is just row difference, and I prefer the row difference, which is a bit simpler. Okay, so then depreciation rate equals data log data 2 colon and minus log data 1 colon and minus 1. Right, and oh no, the first column is the depreciation rate, so I have to put comma 1 and comma 1. Okay, here the change rate is the first column of the data. Okay, so then this is the depreciation rate. Okay, and then according to the UIRP, the dependent variable is depreciation rate, and then y equals depreciation rate. Because the interest rates are in percent, so then I have to multiply 100 here, 100. Okay, so then this is what? This is depreciation rate in percent. What is X? What is X? Okay. Okay, what is X? Okay, let me go back to the data first. Data again. Here, okay. So then this data starts from what? The January 2004, right? But here I did log difference, and this depreciation rate data starts when? It starts from February 2004. Okay, February 2004, right? Okay, so then okay, let me go back to the UIRP a bit more. Okay, here. I think here. Okay, according to the UIRP, here is the depreciation rate, YT. Okay, and this is depreciation rate at time t, right? And then what is the independent variables? Independent variables what? Interest rate. Interest rate when t minus 1, right? IT minus IT star. IT star means the full interest rate, t minus 1, right? So this is the independent variables, right? So then if your IRP is correct, then depreciation rate should be equal to cross-country interest rate, right? On average, of course, there could be error term. There could be error term because this is a prediction error, right? So then this is the predicted depreciation rate if the UIRP is correct. Okay, and then this is what? This is the realized depreciation rate, right? So then this realization can be always different from the our expected depreciation rate. So then there must be prediction error, right? So then the point is that this is the depreciation rate at time t, and this is interest rate differential at time t minus 1. And then so then dependent variable should be lagged variable, right? Right. This is the point. Okay. Right. Okay. So then art tab. Right. Okay. Then right. So then this should start from where? Again, start from where? Here. January 2004. Okay. 2004 January to when? Here 2012, January 2012. So this is from February 2004 to January 2012, right? And then, okay, let me X is where? X is where? Just for now, okay, this is from this second, let's get this from the second observation. So data, this is 2 colon end, and this is second and third, right? Right, this is interest rates. right? Interest rates. Okay, so then I would say this is y0, x0, and then x should be what? X should be what? X is what? X is the interest rate differential, which means, right, which means what? X0. Yes, come on in. Sorry.